Good evening everyone. Now today we'll discuss problems on discrete time periodic signal. The first problem, x of n equal to -1 o to the power of n. So now this type of problem we have to check by using the equation x of n equal to x of n plus capital N. Both are equal or not equal. If both are equal, the given signal is periodic signal, else it is an aperiodic signal. So x of n is given here. We have to check x of n plus capital N. X of n plus capital N equals to -1 -1. Here small n will be replaced by n plus capital N. -1 whole to the power of n, -1 whole to the power of capital N. Now if x of n plus capital N is equals to -1 whole to the power of n, if I want to get this -1 whole to the power of n, this value should be equal to 1. -1 whole to the power of n should be equals to 1. Suppose if I placed here capital N equals to 1, here we will get -1. Capital N equals to 2, if I placed here I will get +1. Therefore, if capital N equals to 2, capital N equals to 2, we will get -1 whole to the power of n. This value is 1. 1 into -1 whole to the power of n is -1 whole to the power of n. Then x of n plus capital N is equals to x of n. Therefore, the signal x of n is a periodic signal and its fundamental period is 2 samples. Go for the second problem. X of n equals to u of n minus 3. In order to make the given signal is a periodic, the first condition of the periodic signal is the signal has to be defined for all values of n from -infinite to +infinite. But here the given signal x of n is defined only for n is greater than or equals to 3. Therefore, the given signal is an aperiodic signal. Third problem, x of n equals to -1 whole to the power of n square. Now again this problem I have to check the given signal is a periodic or aperiodic by verifying the equation x of n equal to x of n plus capital N or not. So let us calculate x of n plus capital N. X of n is given. I have to replace n equals to n plus capital N. X of n plus capital N equals to -1 -1. Here n square, n plus capital N whole square. -1 as it is. Here a plus b whole square, a square n square plus b square capital N square plus 2 into a into b, 2 into small n into capital N. So expand this one, -1 whole to the power of n square, -1 whole to the power of capital N square, -1 whole to the power of 2n into capital N. Suppose x of n plus capital N, I should get -1 whole to the power of n square. This value only I have to retain, means these two terms will become 1. For what values of capital N, this term will become say 1. If I place n equals to 2 here, 2 square is 4. -1 whole to the power of 4 is 1. n equals to 2. 2 into 2 is 4. -1 whole to the power of 4 is 1. 1 to the power of n is 1. Therefore 1 into 1 is 1. So if I place capital N equals to 2, then this total value will becomes 1. Therefore x of n plus capital N is equals to x of n. Here I written -1 whole to the power of n square. This is -1, 2 square, -1 whole to the power of 2 into n. So here I substituted value of capital N. I found capital x of n equal to x of n plus capital N. Therefore x of n is a periodic signal and its fundamental period capital N equals to 2 samples. Fourth problem, x of n equal to e to the power of an. So again the same, verifying the equation x of n plus capital N equals to e to the power of a as it is, small n will be replaced by n plus capital N. Expand this one, e to the power of an, e to the power of a into capital N. If I want to get x of n plus capital N is equals to x of n, means x of n plus capital N, I should get only e to the power of an, then e to the power of a into capital N should be equal to 1. For what values of n, this value is becomes a 1. So e to the power of a into n is not equals to 1. Here only this value will becomes a 1 when a equal to 0 or when n equals to 0. But in the question, a value is given as a is a greater than 0. Hence a value 0 I can't substitute here. capital N equals to 0. So in order to make a periodic signal, its fundamental period should be a positive value. Positive value means other than 0, smallest value other than 0. Therefore n equal to 0 also I not to be considered. Therefore e to the power of n is not equals to 1. Therefore x of n plus capital N is not equals to x of n. Therefore the given signal is aperiodic signal. Fifth problem, it is important. X of n equals to sigma k equal to minus infinite to plus infinite delta of n minus 3k minus delta of n minus 1 minus 3k. Again this type of problems will be solved by using the equations x of n is equal to x of n plus capital N or not. So let us find out x of n plus capital N. Wherever small n will be replaced by n plus capital N. K equals to minus infinite plus infinite as it is. Here n small n will be replaced by n plus capital N. Here small n will be replaced by n plus capital N. Rest of the things is as it is. Here the important point is, if I want to try to make it x of n plus capital N is equal to x of n. If I want to try to make these two are equals, compare here I have a n, in place of minus 3k, here I have n minus 3k. So for this reason we have to substitute n minus 3k, I written here n minus 3k is equals to minus 3k I should get, but k is already here I defined. K is already I defined here. Therefore instead of minus 3k I can assume as a minus 3m. I mean I want to substitute here n minus 3k is equal to minus 3m. Instead of k I taken as a m because k is already defined here. So when k equal to infinite here, when k value is infinite, when k equals to infinite, because I substituted n minus 3k equals to minus 3m means the value of the limit of k value is changes to m. Therefore when k equal to minus infinite, when k equals to minus infinite, substitute k equals to minus infinite here, we will get m value is minus infinite. I will explain. Here minus infinite, minus into minus plus, 3 into infinite, 3 infinite, n plus 3 infinite, 3 infinite. Therefore m equals to minus infinite. When k equals to plus infinite, substitute in this equation, you will get m equals to infinite. So now I will find out the value of capital N here. n minus 3k is equal to minus 3m, n equal to capital N equal to minus 3m plus 3k. Take 3 as a common, capital N equals to 3 as a common, k minus m. So now I am substituting all these values in this equation. So as it is, k equals to minus infinite to plus infinite delta of n plus, here capital N minus 3k I substitute as a minus 3m. n minus 3k I substitute as a minus 3m. Again this equation here, see here, minus delta of n minus 1 minus 3k. n minus 1 is there here. Minus 3k, capital N minus 3k should be equals to minus 3k. Again n minus 3k I want to substitute as a minus 3k, but k is already defined here. Therefore instead of k I have to take another variable as a m. Therefore n minus 3k I want to substitute it as minus 3m. Same thing, already I taken n minus 3k equals to minus 3m. Same substitution is applicable in the first term as well as applicable in the second term. Therefore instead of k equals to minus infinite to plus infinite, it is m equal to minus infinite to plus infinite. It is also m equals to minus infinite to plus infinite. n minus 1 as it is, n minus 3k, n minus 3k I substituted as minus 3m, minus 3m. X of n plus capital N equals to, take common, sigma m equal to minus infinite to plus infinite is a common, and remaining term is delta of n minus 3m minus delta of n minus 1 minus 3m. Now simply I am changing the variable m by k. Therefore delta of n plus capital N equals to changing m to k. K equals to minus infinite to plus infinite, just m to k. Just m to k. Now comparing the equation, x of n plus capital N with the x of n, both are equal. Therefore x of n equals to x of n plus capital N. Therefore x of n is a periodic. And its fundamental period capital N equals to, already I calculated here, 3 of k minus m. N equals to 3 of k minus m. Here the question, what is the value of k and m? I have to substitute. You have to substitute the value of k and m such that you should get the minimum value of capital N. Minimum value of capital N, but n should not be equal to 0. Therefore here I substituted k equal to 0, m equals to minus 1. So we get n equals to 3 of 0 minus of minus 1 equals to 3. Sixth problem. X of n equal to sigma k equal to minus infinite to plus infinite, delta of n minus 3k plus delta of n minus k square. Again, this type of problem will be checked by verifying the equation x of n equal to x of n plus capital N. Both this equation is true or false. If this equation is satisfied, then given signal is said to be an periodic, hence the given signal is an aperiodic signal. So let us calculate x of n plus capital N, just replacing small n by n plus capital N, small n by n plus capital N, small n by n plus capital N. Again, in the previous problem I explained that in order to make x of n plus capital N is equals to x of n, I had to go for the substitution method. What I had to substitute here? Here n is there, minus 3k. Here n is there. N minus 3k I want to substitute it as minus 3k, but k is already defined, hence in place of a variable k I have to choose another variable. Here I choose on the another variable as a m, hence I substituted n minus 3k is equals to minus 3m. N minus 3k is equal to minus 3m. So put when I am changing k to m means here the variable limit k equals to minus infinite to plus infinite is also changes to the variable m. When k equal to minus infinite, substitute value of minus infinite here, you will get m equals to minus infinite. When k equals to plus infinite, substitute the value of k is plus infinite here, find the value of m is also infinite. Now from this equation I am finding the capital N value. What is the capital N equals to minus 3m, this is plus 3k, take 3 as a common, k minus m. Similarly, in the second term, we have here minus k square. Here we have n minus k square. Hence, I have to substitute n minus k square equals to minus k square, but k is already I defined. In place of a k, I am using the another variable as a m. Therefore, n minus k square equals to minus m square. N minus k square equals to minus m square. This is substitution I am using for the second term. Here also same thing. When k equals to minus infinite, what is the value of m? When k equals to plus infinite, what is the value of m? So here when k equals to minus infinite, its value of m is minus infinite. When k equals to plus infinite, value of m is minus infinite. So from this equation, we are finding the capital N value for the second term. Capital N equals to minus m square plus k square. Here I have two values of n. This is n value for the first term. This is the n value for the second term. These two n values I will explain later. So let us substitute these two here in this equation. I am changing k equals to minus infinite to plus infinite for the first term. M equals to minus infinity to plus infinity. M equals to minus infinity to plus infinity. Delta of n as it is, n minus 3k, I substitute as a minus 3m. This is minus 3m. Plus second term summation k equals to minus infinite to plus infinite. K will be changing to m. Again m value is minus infinite to plus infinite. Minus infinite to plus infinite. Delta of n minus k square. I substitute n minus k square, I substitute as a minus m square. Minus m square. Now just to change m equals to k on both sides, we get x of n plus capital N equals to sigma, m will be changing to k equal to minus infinite to plus infinite, delta of n minus 3k, m will be changes to k, m will be changing to k. Now by checking x of n plus capital N with x of n, both equations are same. But whether the signal is a periodic or aperiodic, let us calculate its fundamental period. Its fundamental period, the first term fundamental period capital N equals to 3 into k minus m. Second fundamental period for the second term is n equals to minus m square plus k square. I have to choose value of k and m here such that n should be positive and smallest value. Hence I substitute k equal to 0, m equals to minus 1. You will get here n equals to 3 samples for the first term. For this first term. Similarly for the second term, n equals to minus m square plus k square. I choose the value of k and m such that whatever the value of m you substitute here, you will get n value is a negative value. Hence, is not a positive constant. It is a negative value. If any one are negative, I can say that the given signal is aperiodic. Even the equation is satisfies, but n value is not satisfies for the second term. Therefore, the given signal is aperiodic signal. Go for 7th problem. X of n equal to e to the power of j 7 pi n. So this is called as a complex exponential signal. Here ohm equals to 7 pi. Therefore, I have to use the formula ohm equals to 2 pi by n into k. I have to make this 7 pi in the form of 2 pi by capital N into k. Here pi is there, but there is no 2 pi, there is no 2. Therefore, multiplying and dividing by 2. Multiply and divided by 2. 2 I multiplied and divided by 2. This is pi into 7. This is 2 pi divided by n into k, where k is any integer value. Therefore, capital N equals to 2 samples. Capital N equals to 2 samples, and it is a positive, and this should be an integer value. In case of continuous time signal, capital T should be real value, but in case of discrete signal, capital N should be a what? Integer value. Therefore, x of n is a periodic because n is an integer value, its value is 2 samples. Go for 8th problem. X of n equal to capital A cos of 3 pi n. It is a cos and sine. Again, I have to use the formula of ohm divided by 2 pi by n into k. What is the ohm value here? Ohm value equals to 3 pi. I have to express 3 pi in the form of 2 pi by n into k. Here 2 pi is not there, pi is there, there is no 2, hence I have to multiply and divide by 2. Therefore 2 pi divided by 2. I multiplied by 2 and divided by 2 into this 3 as it is. It is in the form of 2 pi divided by capital N into k. I want to get value of capital N. N equals to 2. Is it a positive? Yes. Is it an integer? Yes. Therefore, the given signal is periodic signal and its fundamental period is 2 samples. Go for next problem. X of n equals to cos of 2n. So, whenever we have a trigonometric function sin and cos, I have to use the formula of ohm equals to 2 pi by n into k. Here, what is the ohm value? Ohm value is 2. I have to express 2 in the form of 2 pi by n into k. So 2 pi, here only 2 is there is no pi. Therefore, I have to multiply pi divided by pi. Therefore, 2 as it is, multiplying pi divided by pi into k. There is nothing, means it is a 1. Therefore, 2 pi by n into k. Here n value is pi. It is a positive, but it is not an integer. Therefore, the given signal is a periodic signal because n is not an integer. Go for next problem. X of n equals to cos of 8 pi by 7 into n plus 2. So this cos and sine, always I have to use a method of ohm equals to 2 pi by n into k. Here ohm value is 8 pi by 7, ohm n plus 5. What is the ohm value? 8 pi by 7. I have to express it is in the form of 2 pi by n. 2 pi. Here pi is there, but there is no 2. Hence 8 I can written as 2 into 4. 2 4 is 8. 2 into 4. Hence I written here 2 into 4. 2 into 4. This is 7 as it is. Now 8 pi by 7 I rewritten as 2 pi divided by 7 into 4. Here hence 2 pi by n into k. Here n value is 7. N value is 7. This is positive and is an integer value. Therefore, the given signal is periodic signal and its fundamental period is 7 samples. Go for 11th problem. X of n equals to 3 e to the power of j 3 by 5 of n plus 1 by 2. It is once again complex exponential. I have to use the same method. Ohm equals to 2 pi by n into k. Here what is the ohm value? So e to the power of this 3 by 5 multiplier j 3 by 5 into n 3 by 5 n plus 3 by 5 into 1 by 2 is 3 by 10. It is e to the power of j ohm n plus 5. What is the ohm value is 3 by 5. Ohm equals to 3 by 5. But this is I have to express in terms of 2 pi by n into k. Here there is no 2 pi. Hence I have to multiply and divide by 2 pi. Therefore 2 pi I multiply and divide by 2 pi. And here ohm equals to what? 3 by 5. This is equals to 2 pi as it is. So this is 5 to the 10. 10 into pi. 10 pi into 3. This is 2 pi by n into k. Therefore here n equals to 10 pi. Now n is a 10 pi is not an integer. Therefore the given signal is a periodic signal. Go for 12th problem. X of n equals to 3 into e to the power of j 3 by 5 pi of n plus 1 by 2. Again the given signal I have to simplify 3 into e to the power of j of multiply 3 pi by 5 into n, 3 pi by 5 into n plus 3 pi divided by 5 into 1 by 2 is 3 pi by 10. Again this is complex exponential signal here in the form of e to the power of j ohm n plus 5. Therefore ohm equals to 3 pi by 5 divided by 5. So this ohm value I have to express in the form of ohm equals to 2 pi by n into k. Here pi is there is no 2 pi. Pi is there, hence I have to multiply and divide by 2. Therefore 3 into 2, 6. 2 pi divided by 2. I have multiplied by 2 and divided by 2. Pi as it is, pi as it is. So remaining is 3 by 5. 3 by 5. Therefore 2 pi as it is. 5 to ja 10. This is 3. 2 pi by n into k. Here n value is 10. Hence it is a positive and is an integer. Therefore the given signal is a periodic and its fundamental period is 10 samples. Go for 13th problem. It's very different types of problem. X of n equal to 1 plus e to the power of j 4 pi n divided by 7 minus e to the power of j 2 pi n divided by 5. Here sum of the periodic signal, this is x1 of n, this is x2 of n, this is x3 of n. Sum of periodic signal gives say resultant periodic signals or not. So in the case of continuous time signal, we are using a ratio t1 by t2, t1 by t3 and so on. Here also we have to use the ratio n1 by n2. I will explain. So this is a 1 is a constant, it is a DC signal, no need to consider. This is a complex exponential, this is also complex exponential signal. Here this is I call as a ohm 1. Ohm 1 equals to 4 pi by 7 expressed in the form of 2 pi by n into k. I expressed here n value is 7 sample. This is I call as a n1, 7 samples. For the second term 2 pi ohm 2 e to the power of j ohm n. Here ohm value is 2 pi by 5. This is I called as ohm 2 pi divided by 5. Again express 2 pi divided by 5 in the form of 2 pi by n into k. You will get here n2 equals to 5 samples. So now go for the step 1. Take the ratio n1 by n2. If I have another n, n1 by n3. If I have another n4, n1 by n4 and so on. Here only 2 n value, n1 and n2. Take the ratio n1 by n2. n1 by n2. 7 by 5. So hence it is a ratio of integer is called as a rational. If the ratio of integers I have here, then the given signal is called as a periodic signal. Second step, how to find out the fundamental period. Step 2 gives the fundamental period. Its formula is capital N equal to L into capital N1, where L equals to LCM of denominator of the ratio. Here I have a ratio. What is denominator? 5. Therefore LCM of 5 is equals to 5. L equals to 5. Substitute the value of L here. Capital N equals to 5 into N1. What is the N1? 7. 7 5 is 35 samples. 14th problem. X of n equal to 5 sine of 7 pi divided by 12 into n plus 8 into cos of 14 pi divided by 8 into n. Again this is the sum of two signals. This is x1 of n, this is x2 of n. This type of problems I have to calculate the fundamental period n1, I have to calculate the fundamental period n2. So here ohm 1 equals to 7 pi divided by 12. Express this in the form of 2 pi by n into k. n1 equals to 24 samples. This is x2 of n. Here ohm 2 equal to 14 pi divided by 8. Ohm 2 equals to 14 pi divided by 8. Express this ohm value in the form of 2 pi by n into k. Here n value is 8. Hence it is called as n2 equals to 8 samples. Now go for the step 1 to check the given signal is periodic or aperiodic. For that you are using the ratio n1 by n2. n1 by n2, 24 by 8, simplify you get 3 by 1 is a ratio of integer, hence it is a rational, therefore x of n is a periodic. Once it is a periodic identified, then how to find out its fundamental period? By using step 2. Its formula is capital N equals to L into n1, where L is called LCM of ratios of the denominator. Here how many ratio I have? Only one ratio. What is denominator value is 1. That LCM of 1 I have to calculate. LCM of 1 is 1, that is the value of L. Substitute the value of L in this equation. Capital N equals to L equals to 1, N1. What is N1? N1 is 24. 24 1 is 24 samples. Go for 15th problem. X of n equal to cos of pi by 2n minus sin of pi n by 8 plus 3 into cos of pi n by 4 plus pi by 3. Here I have three signals are linearly combined. So let us calculate ohm 1. What is the ohm 1? Ohm 2, ohm 3. Ohm 1 is here pi by 2. Express this pi by 2 in the form of 2 pi by n into k. We will get n1 equals to 4. This is ohm 2. Ohm 2 equals to pi by 8. Express this pi by 8 in the form of 2 pi by n into k. Here n2 is 16. This is cos of ohm n plus 5. What is the ohm value here? Pi by 4. Here ohm 3 equals to pi by 4. Express this again in the form of 2 pi by n into k to calculate n3. n3 equals to 8. Now check whether the given signal x of n is periodic or aperiodic. Step 1. What is the step 1? n1 by n2. Next is n1 by n3. n1 by n2, 4 by 16. 4 by 16 is equal to 1 by 4. It is a rational. Next n1 by n3. n1 by n3, 4 divided by 8. 4 by 8 is equal to 1 by 2. Again it is a rational. Therefore the here 2 ratio I have, n1 by n2 is 1 ratio, n1 by n3 is also another ratio. Both are rational and the given signal is a periodic. Then I have to find out its fundamental period by using formula capital N equal to L into n1. Already we know that L is called LCM of denominator of the ratio. This is one ratio. What is denominator? 4. This is another ratio. What is its denominator? Is 2. So LCM of 4 and 2. LCM of 4 and 2 is a 4. Substitute the value of L in this equation. We get capital N equals to 4 into n1. What is the n1 value? Is 4. 4 for the 16 samples. Go for next 16th problem. X of n equals to real part of e to the power of j pi n plus e to the power of minus j pi by 3 into n. So now before calculating I will explain the formula. E to the power of j theta equals to cos theta plus j sin theta. Cos theta is called as a real part, sin theta is called as an imaginary part. So real part of e to the power of j theta is called as a cos theta. Imaginary part of e to the power of j theta is called as sin theta. In the same way he is asking about real part of this whole. Therefore x of n equals to, what is the real part of e to the power of j pi n? Cos pi n. What is the real part of e to the power of minus j pi n by 3? Cos of pi by 3 n. So here ohm 1 equals to pi, ohm 2 equals to pi by 3. Again these two signals are linearly combined. For linear combination of the signals, first I have to calculate n1 value and n2 value. What is the ohm 1? Pi, expressed in the form of 2 pi by n into k, we will get n1 equals to 2. This is ohm 2. What is ohm 2 value? Is pi by 3. Express this in the form of 2 pi by n into k, we will get n2 equals to 6. Now I have to identify whether given signal x of n is a periodic or aperiodic using step 1. Take the ratio n1 by n2. n1 by n2, 2 by 6 equals to 1 by 3. It is a rational. Therefore the given signal is periodic signal. Then I have to find out the fundamental period by using the formula capital N equal to L into n1, where L equals to LCM of denominator of the ratio. What is the ratio? n1 by n2 is 1 by 3. What is denominator value? Is 3. LCM of 3 is 3. Substitute the value of L here and n1 value here. You will get 6 samples. Go for 17th problem. X of n equal to cos of pi n by 4 plus sin of n. Again it is a linear combination of the two signals. Here ohm 1 equals to pi by 4, expressed in the form of 2 pi by n into k, n1 equals to 8. Now sin of ohm n, ohm value is here 1, expressed it is in the form of 2 pi by n into k, here n2 equals to 2 pi. So whether the x of n is a periodic or aperiodic, we have to go for the step 1. n1 divided by n2. n1 is 8 divided by 2 pi. Is equal to 4 divided by pi, but it is not ratio of integer. Denominator is not an integer, it is a pi. Therefore this ratio is irrational and the given signal is a periodic signal. 18th problem. X of n equals to real part of this plus imaginary part of this. Therefore x of n equals to real part of this is cos of pi n by 5. Imaginary part of this means sin of pi n by 10. Here ohm 1 value is pi by 5. Find out its n1 equal to 10. Here ohm 2 is pi by 10. Express this in the form of 2 pi by n into k, n2 equals to 20. Now I have to check x of n is a periodic or aperiodic. Take the ratio n1 by n2. n1 by n2, 10 by 20, 1 by 2 is a rational. Therefore x of n is a periodic. Then its fundamental period capital N equals to L into n1, where L is LCM of denominator of the ratio. Here only one ratio I have, its denominator is 2. LCM of 2 equals to 2. L equals to 2. Substitute the value of L here. L equal to 2. N1 equal to 10. You will get 20 samples. 20th problem. X of n equal to cos of n by 4, cos of pi by 4 into n. Now I will explain this problem using two methods. First method by using the formula cos A into cos B. I written here the formula cos A into cos B equal to 1 by 2 of cos of A minus B plus cos of A plus B. This formula I used here, x of n equals to the product of these two functions. I am converting into sum of those two functions. So hence cos A into cos B. The given signal is not linear combination. It is a product of two signals. Whenever the given signal is a product of two signals, I will explain by using two methods. First method by using the formula cos A into cos B is 1 by 2 of cos of A minus B plus cos of A plus B. So here cos of A minus B, n by 4 minus pi n by 4 plus cos of A plus B, cos of A plus B. So you will get x of n equal to 1 by 2 of cos of n of 1 minus pi by 4. Here n is common. Remaining is here 1 minus pi divided by 4 plus cos of, here n also common, take outside, remaining is 1 plus m divided by 4. Now it will becomes as a linear combination of these two signals. I converted product terms into sum of two functions. This is cos of home n, this is cos of home n. So this is x1 of n, this is x2 of n. Here home 1 value is 1 minus pi by 4. Cos of home n, home value is 1 minus pi by 4. This home value we are called as a home 1, 1 minus pi by 4. This is x2 of n, cos of home n. Here home value is 1 plus pi by 4. That home value here we called as home 2 equals to 1 plus pi by 4. Now home 1 and home 2 can be expressed in the form of 2 pi by n into k. Therefore home 1 equals to, there is no 2 pi here, hence multiplying and dividing by 2 pi. 2 pi multiplied and divided by 2 pi. So remaining is 1 minus pi divided by 4, 1 minus pi divided by 4. Therefore this is a 2 pi multiplied, 4 2s are 8, 8 pi, 1 minus pi. 2 pi by n into k, but k should be an integer, but it is not an integer, hence take in the denominator sign. Therefore home 1 equals to 2 pi as it is, 8 pi divided by 1 minus pi, 8 pi divided by 1 minus pi into 1. Now it is in the form of 2 pi by n into k. Here n value is 8 pi divided by 1 minus pi. Similarly we can express home 2 in the form of 2 pi by n into k. We will get n2 equals to 8 pi divided by 1 plus pi. Here n1 is 8 pi divided by 1 minus pi. Here n2 is 8 pi divided by 1 plus pi. So now I have to check the given signal is periodic or aperiodic. Take the ratio. So take the ratio n1 by divided by n2 equal to, n1 is this n1 divided by n2 equals to 8 by get cancelled. We will get 1 plus pi divided by 1 minus pi. But it is not a ratio of integer, hence it is a irrational. Therefore the given signal is aperiodic signal. The same problem I will explain by using the second method. Here product of these two signals. First signal, I am not using this formula, directly I am finding the first signal is an periodic or aperiodic. Here home, cos of home n, home value is 1 by 4. This is we can call as home 1 by 4, expressed in the form of 2 pi by n into k. So here n value, here 2 pi by n into k. So what is the n value here? N value is 8 pi. 2 pi by n into k. Here n1 is 8 pi, is not an integer. Second, home 2. This is cos of home n. What is home value? Pi by 4. Express it is in the form of 2 pi by n into k. Here n value is 8, is an integer. But the first n1 is an 8 pi, is not an integer, means cos of n by 4 is an aperiodic. Here n2 equals to is an integer, means cos of pi by 4 into n is an aperiodic signal. Here cos of n by 4 is a aperiodic, cos of pi by 4 into n is an aperiodic signal. The multiplication of aperiodic into periodic gives an aperiodic signal. Therefore the product of periodic and aperiodic signal results in a what signal? Aperiodic signal. So any one of the method we can use this type of the problem. Go for the next problem. X of n equal to cos of pi by 8 into n square. This is a cos function. So now I am using here, I can't use ohm equals to 2 pi by n into n. What is the ohm value here? Is pi by 8 is wrong because it is not in the form of ohm n. It is in the form of ohm n square. That's why here I am using the verification of the equation x of n equal to x of n plus capital N or not. So hence first we find out what is x of n plus capital N. X of n plus capital N. Wherever we have small n, replaced by n plus capital N. Small n replaced by n plus capital N whole square. Use a plus b whole square formula here. Cos of pi by 8, cos of pi by 8 of n square capital N square plus 2n into capital N. Therefore x of n plus capital N equals to cos of multiply pi n square by 8, pi n square by 8, pi by 8 into this whole value, pi by 8 into this whole value. So now try to make x of n plus capital N is equals to x of n by putting any conditions. Check it here. X of n plus capital N equals to cos of pi n square by 8. Here also cos of pi n square by 8. But here additional value is pi by 8 of n square plus 2n into capital N. We know that always cos and sin functions are repeats every 2 pi radians. Therefore, if this value is a 2 pi, then cos of pi n square by 8 plus 2 pi is equals to cos theta. Same value I can get it. Therefore, if pi by 8 of n square plus 2n into capital N equal to 2 pi, then substitute this value here 2 pi. So you will get cos of pi n square by 8. Therefore, x of n plus capital N equals to this value. Comparing x of n plus capital N equals to x of n, you will get both equations, both are equal. Therefore, the given signal is a what signal? Periodic signal. Then what is fundamental period? I have to find out the fundamental period using this condition what already I substituted. What we substituted, pi by 8 n square plus 2n capital N equals to 2 pi. Therefore, n square plus 2n capital N equals to 8 to just 16 pi divided by pi. Pi get cancelled equals to 16. So we have equation capital N square equals to, we have equation n square plus 2n capital N equal to 16. So now I have to find out the value of capital N. By putting the small n equal to 0 here, I have calculated n square equals to 16, n equals to 4 samples. So hence the given signal is a periodic, its fundamental period is 4 samples. Thank you.